Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Najihatul Ummi binti YUSUF. I'm from DPC3B and my registration number is 33DPC20F1035. And this is my teammate, ANIRA
Assalamualaikum. My name is ANIRA binti RADZAL and I'm from DPC3B. My register number is
Today we are going
DJJ30113. Today, I am Fatin will present about task 1. It's about tensile test on mic steel. The objective of this task is to study the mechanical properties of the mild steel specimen under tension load. And the apparatus we use is universal testing machine, dial indicator, extensometer, scale and vernier caliper. Step 1. Measure the initial diameter of the tension test sample in two perpendicular directions using vernier caliper. So, DIX is equal 12.55 mm, DIY is equal 12.55 mm. The average initial diameter D is equal 12.55 mm. Step 2. Measure the length of the specimen between the grips using a scale. So, the length of the specimen between the grip is 192 mm. So, punch marks are made at the distance of 2.5 diameter. So, the distance 2.5 D is equal to 2.5 multiplied 12.55 mm is equal 31.38 mm. Next is insert the specimen into its position and mount a tensiometer on the specimen. So we put the specimen into the position, drag the specimen to the mount of a tensiometer. So next is reading on the dials A and B of a tensiometer are adjusted to 0. So dials A and dials B we need to adjust it until 0. So least count of the tensiometer is equal 0.01 mm. Step 6. Experiment is conducted. Load is conducted. As tensiometer reading are read at regular interval of load up to the yield point. Ivory scale reading are noted till the specimen failure. So first of all, we need to push the red button and download the data. So for step 7, I will pass to Fatin. Thank you.
Thank you, Anis, for explaining from step 1 until step 6. So I will explain about step 7. As you can see, this is graph load versus ivory scale reading, and this is use point, and this is an ultimate load. So this is graph for load versus tensiometer reading, and you can see the slope. Slope is 2.18. You must join two pieces of the list test of the test sample and measure the diameter at the neck of the specimen. So the final diameter is 7.475. And for the step 10, we must measure the final length between the three punch used vernier caliper. So the final length between punch mark is 86 mm. So for the observation and calculation, we will calculate yield stress, tensile stress, modulus of elasticity, and percentage elongation and percentage reduction in area. To calculate yield stress is load at yield point over AO. So you can see the yield point at the graph is 35 and the AO is 123.64. So how to calculate is 35 over 123.64. So the answer is 283.079. For the tensile strength is the formula is ultimate load over AO. The ultimate load is 47. Press the button ENG on your calculator. The answer is for tensile stress is 461.015. Modulus elasticity is slope multiplied with 1 over LC multiply KOSNAN over AO. So the slope is 2.18 multiply with, this is the LC, 1 over LC 0.01 218, and then Gosling is 120 over AO. The AO is 123.64. The answer is 211.582. For the percentage elongation is, the formula is final diameter minus 123.64. Formula is final diameter minus AO over AO. So the answer is 93.95. 93. And for the percentage reduction, the formula is, so for the formula percentage reduction in area, the formula is AO minus final area over AO. Calculation is 123.64 minus 43.86 over 123.64. Multiply with 100 and we got 64.52. So we check the answer. So here is the answer. Observation and calculation, and here is the result. That's all from us for this test on steel. Thank you.